Okay, so to look at some examples of some hyperbolas and ellipses, for number one, you're given that the equation x squared minus 6y squared plus 4x minus 12y minus 14 equals 0, and you want to identify what it is and then graph it. Well, the way we identify it is by looking at the coefficients of the x squared and the y squared term. If they are different signs, then it must be, and they're both squared, then it must be a hyperbola. Then the second thing we do is we have to complete the square on the x's and the y's. And so we group things together. So we get x squared plus 4x. And then we have this 6y squared. And so we've got to figure out what to do with that. And so we're going to put the negative 6y squared and minus 12y together. And then that's going to equal 14. Now, when we complete the square, this one's pretty easy to do, right? But the 6y squared one is not so much. And so what we need to do, we'll just go ahead and complete the square on the x's, right? So you get x plus 2 squared. But for this one, we need to factor out the negative 6y so that we get something left inside that is fairly easy to complete the square on. Y squared plus 2y. Half of 2 is 1. Square it, you get 1. And so we add 1 inside. Well, here we added 4 over here, so I'm going to go ahead and add that 4. But then on this one, what we did is we added a negative 6 because we put the 1 inside the parentheses. And so since we put it inside the parentheses, we are multiplying it by a negative 6. And so to create that 1, like I've got it now, I had to actually have negative 6. And so what I'm actually doing is adding negative 6 to both sides of the equation. And then from there, that gets us x plus 2 squared minus 6 times y plus 1 squared equals 12. And then we divide through by 12 to get our equation, which is x plus 2 squared over 12 minus y plus 1 over 2 squared over 2 equals 1. Now we can graph that based on what we know about hyperbolas. First thing we know is that our center is going to be negative 2, negative 1. And so we're going to have negative 2, negative 1. And so our center is going to be right there at that point. Underneath the x is 12. And so we take the square root of that, which would be 2 root 3. And that is going to be our a value is going to be 2 root 3. And then our b value is just going to be root 2 because we end up with a 2 there. And so that means that our c value is going to be square root of 14 because a squared plus b squared equals c squared when you're dealing with hyperbolas. But since we've got a is 2 root 3 and b is root 2, then we create this box that a is with the x, right? And so you're going to go 2 root 3 to the left. 2 root 3 is somewhere between 3 and 4. And so it's going to be somewhere like this. And then 3, a little bit more than 3 that direction. Root 2 is like 1.4, and so it's going to be up a little bit. And so this is the box that we create. And that box will allow us, once we draw it in nicely, to draw in these really nice asymptotes. And we know that it opens left and right because the x is the positive one. And so our hyperbola is actually going to look something like this. That's what our hyperbola will look like. And then to find the foci, all you're going to do is you're going to, it's going to be negative 2 minus root 14 minus 1 because we need to go this direction right here is root 14. So we're subtracting root 14 to get that one. And then the one over here is going to be negative 2 plus root 14 and then minus 1 as well. Those are what your two foci would be. And that would be the graph of this hyperbola. For number 2, same thing, except this time the x and the y's are both positive. So that means, and not the same. So it must be an ellipse. So we'll do the same thing. We've got this 4. We're going to factor out. So x squared plus 4x. We're going to have to put something inside there. And then factor out a 2 for the y's. Y squared minus 6y. And I have to put something in there. And that equals 2. The thing we'll put here is 4. Because we did the 4 inside the parentheses, that means we're multiplying it by 16. So we've got to add 16 to both sides of the equation to create this 4. Same thing over here. We're going to put a 9 there. Half of -3 is, or -6 is -3. Squared is +9. But then because of the 2 in front, we've got to multiply by 2 to get 18. And so we're going to add 18 here. So that's going to give me 4 times x plus 2 squared plus 2 times y minus 3 squared equals 36. Divide through by 36 and we get x plus 2 squared over 9 plus y minus 3 squared over 18 equals 1. And so that means our axis points, well, first off, our center is going to be -2, 3. Move this down a little bit so I got some room. So -2, 3 is going to be the center of this ellipse. Because the 9 is underneath the x part, we're going to go 3 in either direction, and that's going to be the minor axis, the endpoints of the minor axis, because 9 is less than 18. Remember, the minor and the major axis for an ellipse, the bigger of the numbers is the major axis, and the axis is the one that it's underneath. It's the denominator of, and so since the 18's the denominator for the y squared term, then that makes it the major axis. And so square root of 18 is a little bit more than 4, around 4.2. And so that means we're going to go up 4.2 there, and then down 4.2 there. And so our ellipse would look something like this. And then if we wanted to find our foci, remember on these, the a squared equals b squared plus c squared. And so the a squared is 18. B squared is 9, and so that means c squared would also be 9, because, well, c would end up, but c squared would also be 9, which means c is going to equal 3, and so our foci would be at these 2 points right here, which would be -2, and then it would be, what, 5, or 6, because you're going 3 up from -2, 3, and then over here would be -2, 0 would be what your foci would be. And then the endpoints in the major and the minor axes you can find as well by adding and subtracting things. All right, last one here. Taking a look at this problem. You, again, do the same thing. So the 4x squared. Now notice there's no other x term, and so we don't have to complete the square on the x squared term. On the y squared, all we have to factor out is the negative, and that's going to equal positive 61. What we'll be adding here when we complete the square is 25, because half of -10 is -5, squared is 25. But what we're actually doing is adding -25 to both sides because of this negative. So that gives me 4x squared minus y minus 5 squared equals, and then this will be 36. It's a negative, so this is a hyperbola. Divide through by 36, and we get x squared over 9 minus y minus 5 squared over 36 equals 1. This time, it's also opening left and right, even though, remember, on a hyperbola, it's which one's positive that tells you which direction it opens. And so even though the a is going to be 9 is smaller here, that's okay, because for this one to find c, it's a squared plus b squared equals c squared, and a squared is going to be 9 and b squared is going to be 36. So a equals 3 and b equals 6. And so c just turns out to be 3 root 5, right? Because c squared is 45. So when we graph it, our center is going to be, well, there's nothing with the x squared, so that gives us a 0 for the center for the x coordinate, and then this would be positive 5, so it's going to be 0, positive 5. And then a is 3, and it's under the x squared, so when we create our box, we're going to go 3 this way and 3 this way. B is 6, and so we're going to have to go up 6 and down 6. And so we can draw that in, and then we can go through and do the asymptotes, which those ones are fairly easy to find the equation for. You got a y-intercept of 5, a slope of 2 and -2, so -2x plus 5 and -2x and positive 2x plus 5. And then the actual hyperbola looks like this. And then your focus, since c is 3 root 5, is going to be your y value would be 5 for both of them, so it's going to be negative 3 root 5, comma 5, and 3 root 5, comma 5. And, it's just a little bit less than 6. It's more than 6, but less than 7 when you do it.